In this session, I'm going to talk about one of the more complicated subjects, and that's threading and the EDT. Threading in general is one of the harder things in programming, not because of the immediate things, but rather the less obvious implications of some behaviors when it comes to threads. And there's a lot of nuance when it comes to threading. I'm not going to go into that nuance and mostly leave that to the more advanced thread theory books and things related to that. I'm going to talk mostly about threading in a higher level, which is one that we mostly apply in Codename 1. But notice that a lot of things, when people rely on behaviors of the Java virtual machine memory model, like double locking semantics and things like that, if you're familiar with that, don't try to be adventurous when it comes to Codename 1, because it's about portability. And one VM will behave in one way and another will behave in another way when it comes to the memory model. We can't keep up with the same level of accuracy that standard JVMs keep up, because we translate to native code. And this is sometimes very challenging to do. So even experts sometimes have an issue with doing the nuance. So try to keep threading as simple as possible and use it just as much as needed and no more than that. So about threading, the most important thing in Codename 1 is the event dispatch thread. And that's essentially, Codename 1 is single threaded in the sense that you have that thread, and that thread alone cannot access the user interface, or should access the user interface, actually, is the correct term. You can open other threads, and the network sits on a different thread, and there are other complexities related to threads, but generally, as a whole, Codename 1 is considered a single-threaded environment. That means it's not thread safe. There aren't many APIs in the modern era that do thread safe APIs to developers, and that's because it's just almost impossible to do that correctly. AWT tried to do that at Sun Microsystems, and to this day there are open bugs that are just unfixable in AWT in terms of threading, because it's so damn hard to get thread safe to work correctly. So the approach there is to go the exact opposite direction and try not to be thread safe at all, and then also optimize the code as a result, because locking is one of the most expensive things you can do in terms of low-level APIs. And when you need to render things, to draw things on the screen, you don't want to waste time with one of the most expensive APIs you can use. So you don't want to do it often or much. You need to do it to some degree, because there is absolutely no choice. Actually, we need to do it, so you don't have to. The EDT uses locking inside it, but you in your code don't need to, as a result of the existence of the EDT. So the OSs themselves have their own event dispatch thread. This is pretty much for all OSs, and it doesn't necessarily act as one native underlying OS thread, but usually when an application is instantiated, it gets one thread that's allowed to access the native system user interface, and that's it. And that's per application usually. And we, with our EDT, essentially hide the native event dispatch thread. And that sounds redundant. Why have two EDTs? Why have a native one? And why not just expose that directly to the developer? Well, that's very unportable. And the native EDTs behave very, very, very differently between OSs. And they don't have all sorts of abilities. Not all of them. Some of them do, but not all of them have something like invoke and block. And when we want, one of the things in Codename 1 is that the secret to its portability is first lightweight components. But the second secret, which is arguably bigger, is the fact that we have the EDT, and the EDT makes sure that events arrive at a consistent way and at a consistent behavior. And with the native thread, you wouldn't be able to get the same level of consistency throughout. So that's really important for the overall portability. And I normally try to avoid charts in my videos because I'm not a very visual person in terms of structural thinking. But in the case of the EDT, it's sometimes hard to explain what is actually going on. So I did a really trivial chart that I'll later enhance to explain another idea. And the basic EDT is just a while loop, and this is something that people need to understand. It's an infinite while loop that just runs as long as the Codename 1 application runs, and it paints, and then it sleeps, and it paints and it sleeps. And the sleep, by the way, is a very important part of it, because when you do threads, you need to